Okay, welcome to our class. Friday, March 31st, 2023. All right, just so you know, I'm going to raise the awareness as a reminder. If we go to the content tab and we scroll down right to the student items and housekeeping, and if we go to our class course plan, you see the PowerPoint. Now the web browser can see what's on your screen. Huh. Can see what's on my screen. All right. Let's see here. New share. Share. There you go. Can you see the class portal right now? Okay, good. I just had to do it twice. And for some reason, I can't stop unsharing. Oh well, beauty of Zoom. Beauty of technology. At least you can see things now, so that's good. All right, so when you see this class portal, again, let's see again. Here's our class portal. We go to Content tab right here, and we go to Student Items, and we go to Housekeeping, and go to the course plan right here. We scroll down, look at our course plan. This is our theory classes, for example, and I have broken down to the weeks. Can we just zoom in a little bit? Zooming in Zoom. All right, at least I hope things are being recorded. I have the option of stopping the record, so that means we are recording. I'm just making sure. All right, so when you look at our course plan, week 13, we are at the end of week 12. This is the Friday, March 31st, 2023. Right? Next week is week 13. Just keep in mind, look at this here. I just put it out in purple letters. April 7th, it's a Good Friday, 2023. So if you have any plans on making any makeup or performing any makeup labs or anything like that during some of the open lab sessions, our open lab session is week 14. And I don't think we have any labs on Fridays, but with your other classes, if you have any labs or any kind of work planned for the Friday, just keep in mind that this Friday coming up, week 13, April 3rd to April 6th, that is going to be a Good Friday. April 6th and April 7. What's going on? April 7. That should be April 3rd to April 7. But I just put April 6 because that's when we're going to end our week. That's good. It's all good. So just keep in mind, April 7 is going to be Good Friday. That means no school. School will be closed. Right? Just giving you that heads up on things. All right. Now let's continue with this. All this information I'm giving you right now, it might seem a little bit overwhelming combined with all the other classes that you do, learning this, that, and the other thing. I'm just going to say to you, just relax, all right, and just let it give yourself some time. It might be overwhelming, the whole thing, everything at once, things that you're learning in this subject and things that you're learning in other subjects as well. If you are concerned about, okay, how am I going to grasp the whole thing at once and all that stuff? Don't worry about it, all right? Just concentrate on one thing at a time. We're talking about this thing today. Concentrate on at the moment on what we're talking about, and all the other stuff. All the other stuff, do the same thing. Don't worry, when you go to sleep at night, the whole thing is going to settle in you. And once you come to the specific situation on the job, it's all going to come back. All right. So, just another kind of piece of advice that I'm giving you for free. Well, I still get paid for it. All right. Okay. So let me just. There we go. Interesting. Do you guys see some like a smaller version of the screen here? Hmm. Well, I guess that's what we're going to have to work with. Looks like the Zoom is being funny on us today. All right, so this would be the. Oh, I don't like it. You know what? We're just gonna go by this, so we can see things better. All right. So remember, we're talking about the different installation stages, what you can expect when running cables. Yes, you're going to have to know all about the electricity and all that stuff. Yes, it is extremely important. Uh, However, sometimes when you go to the so-called real world, there will be other things that some of them you're going to learn on the job, but I'm giving you a heads up of what you're going to be dealing with this thing here. All right, so we talked about different types of structures that you're going to encounter while, well, wire installation or wire pulling and device installations in the structures is also as important as knowing the Ohm's law. Right? Uh, well, as I always say, nobody is going to pay you to calculate Ohm's law with certain things. However, you might not be hireable if you don't know the Ohm's law. Right? So that's how things work. Right? But what they will pay you for is installing things and making things work and completing tasks that the client requests. All right. Excuse me, I just got to clear my. I was talking for the last hour. All right, we're good. So we were talking about the exterior walls and the need to install something that's called the poly pans, and it is extremely important that the outside walls are sealed with the vapor barrier. All right, so there's a reason why that's followed. If you see this installed, that means this is an exterior wall and this is an exterior wall. What's an exterior wall? It means a wall that separates the inside from the outside. What other walls could be? There could be interior walls that are internally installed that separate maybe one room from the other. Right? When it comes to exterior walls, it is important to keep the vapor barrier intact. If you install any sort of device or device box, you are going to disturb the vapor barrier, which means you're going to have to seal it back with that red, it's called tack tape, TAC tape. So the vapor barrier still remains intact. And when you install devices, you're going to install them in something that's called poly pans. Right? Yeah. And it's a good idea to have a lot of those. They're extremely cheap, and you can buy a lot of them. So there's no excuse for you to not have it when you need to use it. All right. And this is how we install the poly pans. Before the vapor barrier is installed, you just staple that or just include that. You don't even have to staple that to the studs. You just put your devices inside the poly pans, and the people who are going to install the vapor barrier, they're going to take care of that. Or if the vapor barrier was already installed, then you're just going to have to make sure yourself that the whole, after being disturbed, the um, the vapor barrier is intact again. So again, here is the poly pans, and we only need to use them, those poly pans, and we only need to use them when we're dealing with the vapor barriers. If we don't do that, this is what can happen. The moisture can get in there and it's going to get trapped, and you're going to have a problem on your hands. The black mold is going to start developing inside the wall, and it's going to take some time before you start noticing it. And when you start noticing it, that means it's eaten away through the drywall. It's coming on the other side. When you see this, that means on the other side there's a huge mess already that was brewing for a long time. All right. Now, I'm not going to go into the details of what black mold can do to you. However, if you see that there's a black mold, just get out of the room. Right? You don't need to breed that thing. Don't spend any more time than you have to, which means you don't have to spend any time in there. Just leave. And there are certain companies, certain ways of dealing with the black mold. It is not that easy, as easy to it's not easy to get rid of, but there are ways. But let the professionals deal with that. All right. Don't do any work when you see the black mold. Just get out. Right? All right. So you can read that. See, I'm not a doctor, but I was able to pull some sort of common knowledge out of the commonly available materials just to raise the awareness of what the black mold can do to you. All right. Now, there we go. So we talked about the exterior walls. Now, what else? How is it that the whole wire pulling and installation, because if you have to install certain devices, you're going to have to connect them to something. How are you going to connect those wires, connect those devices to wherever they have to be connected? Well, you're going to have to run wires, and running wires is not just see what you can do and just run some wire whichever way you can, and hopefully nobody's going to have to touch that again. It's not like that. There are certain structured ways of doing projects like this commercially. As I always say, if you have to run a wire or two inside your home or your basement, you can take all the time in the world that you need. And if you do this wrong, you can undo it and do it again, whatever, right? However, if you're doing this thing commercially, you're going to run multiple wires because how do you connect things? The red thing to the blue thing? Well, using wires, using cables. And there are certain cable installation techniques that I'm going to kind of, well, give you a heads up on. All the rest, this is the PowerPoint presentation. And of course, we know that watching a PowerPoint and actually doing something, there could be a huge difference. But at least you have some anchor, some starting point of what to look for, and then you're going to have to let your experience to take over once you actually get to do those jobs. So one of the stages of running wires in wire installations is something that's called a roughing in, rough in, rough in stage, okay, of doing things. What is a roughing in? Roughing in is basically pulling a wire to just where it's supposed to go on both ends, but we are not terminating that. We're just laying those wires in. So over here, we have, well, could be data cables, could be electrical cables or whatnot. You're just bringing them to roughly where they're supposed to be and coil them in the ceiling. And on the other side, usually it will be for, in our case, could be electrical panel, or it could be a rack location for data cables. Wherever the home run is, you do the same thing. You bring them there and you just leave them there so you can come back and do the installation. I took some pictures. This is an example there was a few years ago, I did a small job, residential. This was the destination point where the data wires will go. And also, it could be the destination point for the electrical wires. So the home run for this small job was here. Look, it's a rough in stage, roughing in the wires. What is it that I did? I pulled the wires to the location and I coiled them up. Notice what I did here. I put them in the foil bag, on the plastic bag, in the plastic bag, taped it around and tucked it away because I know that before I can do my termination, I have to wait for some other trades to do their work. There could be some air duct people, there could be some drywallers installing, and people who install the floors. And so sometimes you just do what you have to do in that roughing stage. And then you leave and you come back when the site is ready for you to come back. But you can't just drop it on the floor because people are going to step on it. They're going to move it out of the way, and when you come back to it, you're going to have to pull new wires, right? So just keep that in mind. Now, this is a small job. Usually, with the commercial jobs that you're going to do, you are going to have that thing coming out of the ceiling somewhere, or sometimes in the floor. So just make sure that you coil things and put things away properly. Well, that's what I can say. Properly, right? Means that it can mean different things according to the situation. Basically, what you want to establish is avoid the possibility of those wires being damaged by other trades. So that was the roughing in stage. What's next after you come back? You're going to do the destination prep. What it is that I wrote here? Destination. All cables are pulled down to boxes and grommets. So once you pull those to location right here and coil them up, excuse me. Then you're going to come back and do the preparation. So here's an example of what can be done. You're going to arm yourself with different set of tools, which is kind of making things more efficient. Doing things in stages makes things efficient. Right? You arm yourself with one set of tools, you perform one specific task, and you do this thing repetitively, so you are more efficient in doing this job, right? As opposed to pulling the wire from one end to another, and then you're going to have to change your tools and do a termination on one side and come back and do a termination. It's going to take you forever. If you do things this way here structurally, then you have a chance of actually making money on on this thing, right? So after those things are being roughed in, then you come back whenever the site is ready for you, and you're going to run those to the boxes. Now, at the rough in stage, you can coil them here above, or sometimes you can run them to the box and coil them there. Now, which one do you do? You're going to have to decide. If there's a chance that there's going to be some other work being done here that is going to disturb your wires, then you're going to coil them here. If you know that if you don't run them through the boxes, through the studs here and to the through the timber into the box, and there's going to be drywallers before you can do that, they install the drywall, then of course you're going to, it makes more sense to do, to run your wires into the boxes and coil them there and come back to them to terminate, to do the termination. So you just have to decide and judge it by, every situation is different, right? So that's what happens at the destination. So destination prep, you just go and do whatever it needs for that termination to be there, to happen. Now sometimes you terminate those wires putting a jack or putting a duplex receptacle, whatever, right? And I'm getting, so this is something that we're going to be dealing with next term with us. We are kind of ahead of our time, so I might as well give you what we're going to talk about next term. Plus, it all kind of goes together, this course and the next course. And sometimes you will be able to put the faceplates on and install the jacks or receptacles with the faceplates. Or sometimes what I do is I put those jacks or receptacles in a plastic bag and just kind of tack them in there. Depends on the situation. Because you don't want to put a nice, beautiful faceplate with the jack on that thing and have the painters come over and just paint that over. Excuse me. You don't want to put a faceplate on because the painters, they're going to do as good job as they can, but always there's a chance that things are being painted around. It is easier for the painters if the faceplate is off, so you just don't put that faceplate on. Have that jack, put it in a plastic bag, tuck it in there, come back to it after the whole thing is painted. Then you can put the faceplate, the jack into the faceplate, put the faceplate on, screw it in. All right, and then things are looking beautiful and professional. So that's the destination end. At the home run end, you're going to wrap things in and leave it there in a coil. But when it comes to the destination prep, you're going to uncoil that, transfer the numbers from, because the numbers, the cable should be labeled at both ends, so you know which cable goes to what destination, and according to those labels you're going to terminate them either in a patch panel, it's a jack, or you're going to terminate them in the electrical panel if you're dealing with the electrical installation, right? So you're going to have to uncoil them, make sure you have all the cables, no labels are falling off. If they fall off, you have to make sure that you know which cable it is. You might have to trace that cable or two, and then you're going to transfer those labels to a comfortable positioning, so you could find them nice and easy, and they're going to stay there. So when you have to come back and service, you're going to have to see those labels there, and then you're going to do a termination at the head end. All right. Termination destination. All right, so this here I'm not going to touch on because this is something we will be dealing with next term. However, what I'm going to do is I am going to get another presentation, and we're going to continue with that. Right. I'm going to combine those slides from that presentation and throw out those slides that we don't need this time, and I'm going to combine these slides and I'm going to make a new presentation, a new set of lecture notes, and I'm going to upload them so you can study them. All right. Now, I wonder. All right, with this one we can. You still see the big screen, the good screen, and with a bunch of wires here, and something that says site work, and my beautiful face somewhere in the picture there, right? Right? Okay, good, cool. All right, so site work, roughing in, another take on that. After planning the cable distribution, because you're going to go through all kinds of different planning stages, all cables are pulled from the home run. So this is what I said, from the home run location to their destination. The cables are coiled in bundles at both ends, but not terminated. Make sure that the cables are clearly identified at both ends. That's extremely important. If you're dealing, as I always say, if you're dealing with one or two cables, no problem. You can trace them if you lose their track of where they go and where they come from. But if you're dealing with 400, 500, 600 wires, then labeling them at both ends is extremely important. All runs are securely mounted in a ceiling space or otherwise raceways, and the work is done according to the local building and electrical code. For the most part, you're going to, if it's data, you're just going to be dealing with the type of insulation that's being used. If it is electrical wires, again, same thing, right? Some of the wires you can run surface mount exposed, like NMD90 can be mounted exposed. As long as it's done certain way. You can't mount it directly on metal surfaces. It has to be on timber, wood, and things like that. And the way things have to be suspended, like for example, data wires. Let's not get ahead of this thing of ourselves here. All right. When it comes to data, so I'm giving you the data and electrical because guess what? You're going to be dealing with both. And sometimes you're going to get a contract that is dealing mostly with electrical wires. So you're going to do some pipe bending, installing raceways and whatnot, and running wires, electrical wires. And sometimes you're going to have an opportunity, or period, that's it. You're going to have to do both. The contract is going to include electrical and data. About 30 or so years ago, you would just deal with the electrical stuff, period. Now, things kind of overlap, and you're going to be dealing with data a lot. So that's what we're going to talk about next time we see each other in our summer course. But I'm giving you this here because a lot of this data and electrical, as far as installation, they overlap. They use the same rules, right? And we might kind of go over that again in the summer, but it's just going to be even like better for you because you're going to retain that thing better. And maybe if you get some part-time jobs or summer jobs or whatnot, maybe you can apply this knowledge as well. All right, so cable installation begins with establishing pathways, free air runs or raceways. See here, some of the runs are free air, some of them are in raceways. All right, so for free air runs, main runs should be kept in bundles and suspended independently of any ceiling structures. That mostly this thing is dealing with the data wires. So if we go to this picture right here, these are a bunch of data wires that go somewhere from the home run. It would be like a LAN room or communications room or communications closet. Then try to keep them in bundles. Keeping them in bundles gives you advantage of, let's say this is 15, let's say there are 15 wires here. You can run each wire independently, so you're going to have to do this wire pull 15 times. Or you can just bundle them. Running 15 wires as data is not that uncommon. You can bundle them in one, try to look my mouse. You can bundle them in 15 and just do one pull of 15 wires instead of 15 pulls of one wire. Just think about the time, all right, that is going to take you to one or the other, right? So bundle them up as much as I can. And that takes a little bit of planning, looking at the drawings, see, okay, if we pull everything to this point, we'll be able to service this jack and this outlet and that outlet and maybe something in the ceiling here. So this will be a good common point. All right, so let's do it here. And from here, we're going to fan out with those wires. But from here to here, we're going to have one main bundle. All right. So here, main run should be kept in bundles and suspended. Here is the other part of the sentence. Independently of any ceiling structures. That mostly applies to the data because if we go to electrical wires, you're going to have those independently supported anyways. Right? But data, some years ago, It was a common practice of technicians strapping those data wires to the rods that suspend from the ceiling. It's just a metal rods, like a wire rods, um, that suspend from the true ceiling, and they hold the ceiling tiles frame. And it's bunch of a lot of rods. So it's a good anchoring point. People would just go, okay, run the wires. I'm just going to lift them up a little bit. So we're going to strap tie them to those rods, and so they are not laying on the ceiling tiles. That used to be the practice, but later on, people were told not to do that. Every cable run should have independent suspension from any other ceiling structure. Right? The reason for that is mainly, well, aesthetics, or there's more wires in the ceiling now than 30 years ago, because the whole data networking kind of took off big time from the last 30 years. So we're dealing with more wires, and they only have so much ceiling space. So that's one thing. The other thing is, when, God forbid, there is a fire, then you're going to have some fire crews moving in and dealing with what they have to deal with. And sometimes what they have to do is they have to get those kind of hooks on the stick, right? And just have to grab some of the ceiling structure and pull it down, so they can get to whatever they can. It's part of their job, right? So if there's some other things strapped to that ceiling structure, it makes things more difficult, and plus it's uncontrollable environment when they are dealing with fire situation. So it makes their job more dangerous. All right. So that's why we should install wires independently. Uh, Independent suspension should be there. Right? Okay, so as much as possible, that's again, that applies to mostly data wires. However, in some cases, when you're running certain types of raceway, like a wireway raceway, establish straight runs so the pulling multiple cables can be done efficiently. All right, I'm going to go back to this same picture here. If you have to do from straight line from here to here, and you have 12 or 15 wires, yes, one person is going to feed that there, and the other person is going to pull from the other side. You can establish the good flow when pulling the wire. If you have to do a bend around the corner, then there are some tricks you can apply to do maybe one bend around the corner. But if you're starting out, just make sure that you do straight lines. So that's what basically what that thing here means. Now, J hooks. J hooks are, well, more towards data wires. However, some electrical wires are suspended on J hooks as well. That depends on the contract and the situation. So J hooks are mounted on the walls or suspended from the ceiling on something that's called threaded. That's a loaded sentence. Again, J hooks mounted on the walls or suspended from the ceiling on the threaded rods are the most common in this scenario, considering data. That's a J hook right here. I just kind of slapped picture on picture here, just kind of like a symbolic J hook. That's what J hooks look like. No. Mm. All right. So the most common one. Now that would be the free air. All right. Raceways. As the alternative to free air method, closed raceways or cable trays are used. All the raceways should be installed before the cables are run. So remember when we are doing the lab, the three-way switch, and some of us would just pull the wire to one box and then install the pipe to another box and pull the wires. And I was just walking around and said, guys, do the raceway first. Do the raceway first. Why? Because this is what's happening at the construction site, on the site. That's, you don't do You don't do like sweep through the building and install everything, and when you're done on the other side of it, everything is installed. No, you just get the raceway first, then pull the wires in the raceway, then install the devices and terminations and whatnot. That's the efficient way of doing things. All right. Now here's a hint about the J hooks. All right. Uh, Position the J hooks no further than 4 feet apart to avoid cable sagging. When we'll get to that. I'm going to read that again. Position the J hooks no further than 4 feet apart to avoid cable sagging. Okay, I read it twice. We'll come back to that. Threaded rods. It's a common thing that you can encounter during some installations. I'm just giving you the ammunition that you can use to do your job, right? So threaded rods are quite popular because you can do all kinds of wonderful stuff with them. Cool, eh? All right. So what's a threaded rod? A relatively long rod that is threaded at both ends. The thread might extend along the complete length. Usually that's the latter case, the second case. So, excuse me. Go to some hardware store and look at it. All of them will have threaded rods, and they'll have different gauges, like different thicknesses and different lengths. It's a rod, metal rod, that it's threaded all the way through. What can you do with that? Well, you can cut this to length and use it as just like Lego blocks, but for grown-ups, right? So here's a threaded rod supporting some sort of a structure with a tray. All right. Here's a threaded rod suspended from the ceiling, and it's used in combination of strut channel. We'll talk about that in the next slide. Here is a strut channel. That's what it looks like. When you go to do the labs, just take a look around the walls. I bet you in some of our lab rooms you would walk by a lot of those and not even noticing that it's there. Now you're going to see it. Strut channel, well, standardized formed structured roll system. Wow. Used, and I wrote that, used in the construction and electrical industries for light structural support, often supporting wiring, plumbing, or mechanical components such as air conditioning or ventilation systems. Now, see this here? It is something that's called a click to watch. No, it is called a spring nut. What's a spring nut? Here's a nut with a spring on it. Boom, spring nut. You take a nut, you take a spring, boom, you get a spring nut. I think there was a song like that, similar. All right. See this threaded area right here of that nut? Good. You can mount things like threaded rod. You can just screw that in. You can put bolts there to hold other things. Wonderful thing. All of a sudden, you have a structured metal thing suspended from the ceiling, and you can put those spring nuts as many as you want because you can just push them in and position them the way you want. If it's in the ceiling, you do one of those. And the purpose of the spring is just to hold that square shape nut along those kind of lips that can serve as a supporting structure for the spring nut. So it just keeps that in place. Click to watch this video here. It's about a minute and a half, and it just shows you, just gives you the visual of the idea of what it means to install those spring nuts. All right, so strut channel, standardized often is, okay, we already read that. Now here, the next slide is going to be this right here, because sometimes I do this class in person, so I bring it up on the big screen, and this works here as well. Those strut channels come in different shapes. The most common ones will be the half-slotted ones. Although sometimes you can get those punched channel, but this will be the most common one. Yeah. What's this one here? Look at that. Here's a half slotted one. All right. One thing I'm going to bring your attention to, because that strut channel, it can be cut to length to accomplish whatever you need. You can make a wire tray out of that. Or you can support all kinds of different things, like threaded rods, for example. You screw that in. Hey. Here's the awareness that like, something that I want you to know. And I think I'm saving some lives here by saying this, by showing you this, guys. Whenever you're going to have to cut things to length, of course you can use a hacksaw, but if you have a larger project, you just won't be able to physically handle cutting so much metal, and it's just going to be not efficient. So you're going to have to divert to some sort of better ways. There must be a better way, right? There is a better way. Use a chop saw, not a miter saw. Just keep in mind there's a difference between chop saw and a miter saw. Miter saw. All right. So this is a chop saw. Now look what happens here. When this guy is cutting this, well, sparks are flying. That means there's enough heat produced on that contact of the blade and the metal that's being cut that it actually creates sparks. So that means heat is generated there. Whenever you cut galvanized metal, because those struts, they're made of galvanized steel. Galvanizing is a special type of coating that prevents, well, corrosion and other things. When you're cutting galvanized metal in a way that the heat is being produced, you just have to make sure that you understand that whenever that happens, there are fumes being released. And there is some sort of chemical structured way of pronouncing whatever the components are that are being produced. But all you have to know, when you see this and you see galvanized steel, breathing those fumes is not good. And I'm going to say again, seriously, breathing those fumes is very not good. All right. So when you do that, make sure you have well ventilated area, or sometimes you might have to use respirator masks. Whatever you do not breathe those fumes. So here's an article. Why don't you click on that once you have this thing available for download? Click on an article, or you can just Google metal fume fever, and you're going to find out more about all kinds of wonderful stuff. Now, remember when I talked to you about the J hooks, so are not supposed to be more than 4 feet apart? And again, it mostly applies to the data wiring. When you have those J hooks suspended further than 4 feet apart, there is a sagging that happens. Cables are going to sag down. And you might care about that or not. Problem with that is when the cables sag due to too much separation of the J hooks, then you're creating too much pressure right in this point on the wires, and they're being squished, and that's not good with the data wires especially. And we're going to talk about that. J hooks, they come in different shapes. Some of them are plastic and some of them are steel. And they could have different mounting. Now, here I'm showing you the plastic J hooks with a ceiling mount, but they also come in wall mounted version, right? So I just do a couple of pictures of both. So they can be mounted in the ceiling. They can be mounted on the walls, and they can be mounted, oh wait, on the threaded rods. And wherever there's companies, those distribution places that they sell the J hooks, threaded rods, They will also sell all kinds of different paraphernalia to accommodate different situations that you're going to encounter. Sometimes you mount those threaded rods in the ceiling space, mounted to the ceiling, sometimes to the strut channel. Sometimes you have a T-bar. Why not use it? All right. So there's a metal construction in the ceiling when you pop the ceiling tiles. There is all kinds of different paraphernalia to mount those threaded rods, and then you can mount the J hooks, and you can make kind of like a Christmas tree configuration because those J hooks are also rated to handle so many wires before you have to use another J hook, right? So you can just use the space. You can double them up. You can do one this side here, one the other side. Why not? And see here, you can mount a lot on that one threaded rod. So these are the J hooks. Right? Now, when it comes to specifications, they will be specific. You will read this. So you will read those specifications on the J hooks, or sometimes in the cables, but most it's going to be J hooks. It's going to say it can support so many wires of like Cat 5e, or it can handle so many wires Cat 6, or so on. We'll talk about what the categories cables are next time we see each other in in about a month or so, right? Now, the J-hooks can be mounted in the ceiling as well. Just keep in mind, whenever you're making that Christmas tree kind of a J-hook thing, J-hook tree, just make sure you clear at least 6 inches from the ceiling tiles. So this is be the true ceiling. This would be the suspended ceiling here, and that would be the room that people walk in. So maintain about 6 inches here so you don't run into a trouble when it comes to wire installations. All right, how do we install things? Like, for example, the threaded rods, you can use the strut channel. You can do that. But if you have one or two or so, or maybe that's the way it was specified and the boss told you to do it, so there you go. You can start different ways of mounting the threaded rods or otherwise materials, like for example bolts with the J hooks on, right? So threaded rods. Well, this thing is called threaded rod hanger, and that's what it looks like. It has that kind of a screw-like tip here, the body, and then it has the kind of a socket space to grab things on, and it has a thread inside that you can mount a threaded rod in. For this one, you use a hammer drill, and you're going to have, whenever you buy those, you're going to be specified with, they're going to be specified with what kind of a concrete size of the drill bit to use to drive into the ceiling space, or otherwise concrete, well, mostly ceiling space because they are hangers, right? Now, sometimes you're going to have some challenges. You're going to have a clear space. Now, look at some of the specifications of threaded rod hangers, and you'll be surprised how much weight they can actually handle. I'll leave you with that. But no matter how strong this is, the whole system will be as strong as the weakest link. So if you have that can handle so many hundreds of kilograms, there's no guarantee that, because if you can screw that into some kind of a weaker structure, then, well, the weaker structure decides how much you can hang from that, right? Okay. But mostly for this, concrete ceiling, true ceiling here, true ceiling tiles, and the space. All right. So you're going to drive this thing with a hammer drill, and you can screw that in, and you can mount the threaded rod inside the thread. No problem. However, there could be some challenges because sometimes you're going to encounter a perforated ceiling. So you're not going to have a clear access to the concrete. You're going to have a thing covered from the bottom with steel. I would rather have this for mounting purposes, but sometimes you just have to deal with this. Can you use concrete drill bit with a hammer action on that? No, you can't. You just have to drill through the steel first, and then you're going to have to use the concrete bit with a hammer action. And sometimes you have different types of insulation. And I was talking to you, and I'm going to tell you again in our class. MMMF, man-made mineral fibers. Sometimes those ceilings are sprayed with that. When you see some kind of a gunky spray on that ceiling, make sure that you, from whatever the facility is, you can find out and make sure that it's not the MMMF. All right, because if it is, it's pretty much almost or just as bad as asbestos to breathe that in. If it's left there intact, yeah, okay. But if you have to go and muck with that, disturb it, then you're going to have to breathe some of that. And those fibers are so small, they get into you and they don't get out. So make sure. And then there's different types of insulation, and some of them looks like MMMF, but it's not. The only way to do it, to check if which is to take a sample of it and bring it to the lab. But the facility should have documentation on that. And if you're not sure if it's MMMF or not, don't muck with it. All right, another way of miking things. All right, I realize it's okay. So about almost 12 o'clock. So what happens if you have to go, as I always say, if you have to go to another class, please go. And I'm going to post this thing on YouTube so you can catch the end of it whenever you, are able to. Right? We're running a couple minutes overtime here. All right. So another way of mounting things is with drop anchors. Drop in anchors. Drop in anchors. All right. This is an anchor that is being held in whatever surface or space is being held by expansion. So you drill a hole of specific size that is specified by they come in different sizes and gauges as well. So you drill a specific size of hole in there, and you put that in, it just kind of slides in, and then you have a special insert that you insert there, and you hit that with a hammer, and that thing expands, no problem. Now, here's the thing. When you have to do 1 or 2 or 5, okay, you get the hammer drill the specific size hole, put that in, and then you get the insert there and hit it a few times with the hammer. And so it's going to be like when you hit the hammer, it's going to bang, bang, hit, maybe a couple stronger ones, right? After a while, you develop the muscle memory of how strong you get. But then that involves too much effort. Not too much effort because we're lazy, but things come in play when you have to do like 400 or 500 of them. Okay, so then you're going to look for things that speed up the work and produce less stress on your body. So what happens is that there are attachments, and for this you should use a heavier duty drill. So there are attachments that you slide in the drill bit, lock it in, drill the hole, put that thing in, and then you just undo the drill bit and slide in the hammer in insert. And then you put that on and you just press the trigger on the drill. So instead of having to hammer that thing with a hammer in order for those flaps to expand so this thing can be held inside, you just go put that thing in and you just go, that's it. That's how long it takes. So these are the drop-in anchors, and take a look at the specifications of some of them, and again, you will be surprised how much weight it can hold. Here's a little tiny click to watch when it comes to this. Again, it's going to give you a little bit more visual on what these things are. Another way to mount things is, and this is going to be the last slide because I'm not going to talk about racks just yet in this semester. So the last thing I'm going to show you is something that's called the chemical bond mounts or mountings or chemical anchors. Over here in that blurry version out of focus is the cinder block. The cinder blocks are the ones that looks like the oversized bricks that are painted, and we can see them in our classroom walls and whatnot. That's what the cinder block looks like inside, and this is the outside, and there's a bolt. If you mount one of these there, drop-in anchor, again, the whole system is as strong as the weakest point. The weakest point of that system would be the material that the cinder block is made out of. It's more brittle. Some of them, some materials are more brittle than others. Excuse me. If you install that drop-in anchor or any kind of expansion anchor, and if it's a heavy structure, and if it's in a way that people walk by it and they can touch things like there used to be those old TV brackets, um, relatively low. People could press the button. So every time you press the button on the TV, the whole thing wobbles, right? So this whole thing, if it's mounted like that on the wall, it could be wiggled out. So the whole thing can come down on somebody's head. So it's not good. Um, chemical bonds, once they set the whole thing becomes one, and you would have to do a lot of force in order to. So sometimes the chemical bonds are better to use. The one thing with the chemical bonds is that once you install that chemical goo that's there, you gotta wait for this thing to set, and that's usually like 12 to 24 hours depending on the specifications of that. Then look at the specifications again. You'll be surprised what this thing is rated to handle as far as weight. All right, so this is the last slide that I want to show you, and let me just give me a few hours, a couple hours, so I can sometime later on today I'm going to release those posted lecture notes. All right, enjoy your weekend, guys and gals, and I will see you when I see you. Thank you very much.